Here, we are given some integrals. The functions are not given. The only thing is given is that integrals of two functions on two different intervals, from 1 to 5, from 1 to 3, integral of f and g. These are two different numbers. And now the question is asking to evaluate some of the given integrals here. The first thing is that I apply the additivity, then the constant multiple, and now this is 1 to 5, 1 to 5. Now I have integrals of f and g, and I have to try to use the information given. Integral of f from 1 to 5 is given. It is 2, it is 1. How about integral of g from 1 to 5? The integral of g from 1 to 3 is given, from 3 to 5 is given, and now we can go ahead and use the property that integral of a function from 1 to 5 can be written as sums of integral of the same function from 1 to 3 to plus integral of that function, same function from 3 to 5. Why did I do that? Because I know the value of integral of g from 1 to 3 is given 3. Integral of the function from 3 to 5 is given is 5. And that tells me that the integral of gx is from 1 to 5 is 8. So here, then I have 8. This is 2 minus negative 20, 2 minus 24, therefore giving negative 22. How about this other one? Okay, I have integral 3 to 5 of f of x minus, okay, I'm applying the additivity or linearity all at once. Okay. Integral of f, it's given from 1 to 5, from 1 to 3, and now here I am looking for 3 to 5. I will do the same thing. So I will go integral of function f from 1 to 5 is equal to integral of the same function from 1 to 3 plus integral of the same function from 3 to 5. Two of these values are known. Integral 1 to 3 is negative 2. Integral 1 to 5 is 1. Then we have an equation for integral of the function from 3 to 5. And doing that computation, you notice that the integral of the function from 3 to 5 is the number 3. So I have 3 for the first one, minus 3. What is integral of 1 dx? Integral of 1 dx from 3 to 5, isn't that a positive function? 1 is the constant positive, and you go from 3 to 5. The region under the graph is a rectangle, and it has length 2, height 1. So that is 3 minus 3 times 2, which will give me negative. Okay. Later on, you can do fundamental theorem of calculus and evaluate that without doing that any area. But now I'm trying to use what I have here. Okay. The last example here, I have integral. I separate first each one. As I said before, these guys are the form that you can get it from the circle, semicircle, quarter of a circle. 2 minus x squared is the same thing as x minus 2 squared. So I look at the first integral now. Integral of gx from 1 to 3. It is given. It is the number 3 minus 3 times. What is this guy? This is upper semicircle of radius 1, centered at where? At, okay, this is the center at least. So 2 and 0. So if I have the semicircle centered at 2, the radius is 1. So we'll go like that. So it means that it will start from 1 to 3. Now I am going, yes, integral is from 1 to 3. So this is area of the semicircle of radius 1 centered at 2, 0, plus 4 times, well, what is integral of x from 1 to 3? Okay, x has this graph from 1 to 3. I have this trapezoid, or you can see there is a difference of two triangles there. But I can anyway, what is that? I will be able to find all these guys. So 3 minus 3 times area of semicircle, half of pi 1 squared. Pi 1 squared is the area of circle of radius 1. Half of that is area of the semicircle. Oh, where did I put that one? So this is area of the trapezoid, area of the region. Let me just write it here. Oops. The region is, or the shape is like that. So this is 2, this is 1, this is 3, and this is right. So that is that area of trapezoid, right? Trapezoid, or I don't know, difference of two triangles. You do either, and you get a 1 plus 3 times 2 over 2. Three numbers, I found them, I add them, and that will give you the number that we are looking for. I won't do anything else. The only thing I use here is the properties and the given information.